Hello my friends, in this lab we will be diving into the world of OSPF, another dynamic routing protocol. OSPF, which stands for Open Shortest Path First, is a link state routing protocol. It's commonly used in enterprise networks. Unlike distant vector protocols such as RIP and EIGRP, OSPF actually uses a link state algorithm. It exchanges detailed information about network topology with neighboring routers to build a comprehensive map of the network. This allows OSPF to make more informed routing decisions because they are all most up-to-date information. In our lab, we'll be implementing OSPF to enable efficient routing in our network topology. The IP addresses, VLAN network addresses, and network interfaces of the network devices have already been provided for you. OSPF areas used are colored and numbered. Your task is to create the OSPF setup according to the given areas in the topology. A little suggestion here, if you are not sure, you can always put loopback interfaces on the middle routers in the area 0. So it will not be mixed. Now let's discuss a couple of tips to keep in mind during the lab. You should not forget to add the passive interfaces so you can prevent unnecessary devices receiving OSPF advertisements. This actually helps optimizing the network resources and prevents excessive routing updates. Additionally, you have the option to define OSPF directly on the interface, which will help with the setup really much easier. By using the command IP OSPF, an OSPF number, and then area X, where X is the area number that is colored in our topology. So this allows more granular control over the OSPF configuration. So when troubleshooting, you immediately see which area is the problem and that you should fix. By mastering OSPF, you'll gain a deep understanding of link state protocols and be able to design and optimize large-scale networks effectively. And one last note, as you can see, like in the previous lab, the setup is already done. You can just check the with the show commands the OSPF is working or not. But to apply it, you should delete the NVRAM of the devices and you should reload the devices so you can start. So let's embark on this educational journey. We will guide you step by step, explaining about what should we do. One thing to note is that I will not provide detailed instruction on how to delete NVRAM, set up access track interfaces on the switch, or configure the DHCP server and the sub interfaces on the router. However, I will briefly demonstrate these setups one last time so you can make them faster for the later labs. By doing so, this will allow you to focus on the lab topic only. For the switch, I will use the switch template that will be shared on GitHub. This includes VLAN from 10 to 40 on the switch, and each are separated for 5 by 5 for the first 20 interface. And actually, you don't even need to erase the switch NVRAM for this lab. But you can do if you want. As for the router, I will provide a template for configuring the DHCP server. Typically, we are using G02 as sub interfaces, and to ensure the compatibility with the switch, we will be using the VLAN naming for VLAN 10 and 20 for the pools and excluded addresses. This will be also added to the GitHub. Okay, now let's look at the IP addresses. First, are they working or not? From the DHCP server, are they taking it or not? I'll copy this for The other PC also paste. Next. Okay, seems like working. Now I erase the switch and erase the router setups. Then I will reload. Next, check again. Okay, it's failed. As you can see, switch name is just switch. So show run. There's nothing. It's a fresh switch. Now load switch setup. Then the router setup we should first. And reload. Again, check the IP addresses. You see switch name is come, router name doesn't come, but if you look at the running config, it came. Okay, it looks like working. Okay, I will start from the router one first. I already assigned the IP addresses and reload the setups of the switch and the router, and I already get the IP addresses for the PC. So we will just be doing OSPF setup. Config T router OSPF 1. Then we will go to network. I will define all the sub interfaces because they're in one area 1. So let's put it area 1. Then define passive interface G02 and L0. And that's it for my OSPF setup. We can check that it is defined. You can pause it whenever you want to check the details. Enable config T. In this one, I will define the 192.168 interfaces together. So router OSPF 1, network 192.168.0.0. And the wildcard will be 0.0.255.255. This will be area 0. So this interface is done. Next, another interface, loopback interface. This is the second one, 222. This will be area 0, as we discussed before. One last thing is area 1, which is 10.0.0.0. And this will be in area 1. And define the passive interfaces as 0 only. Others are okay. So when we do show IP route, nothing come yet, but protocols, it's come. The things I define one by one is seen on the table. Now show IP OSPF interfaces. You see that 02 is in area 0, 22 is in area 0, and this is in area 1, and the loopback interface here is also in area 0. 10.0.0 area 1. Okay, show IP route. If we do, we can see detailedly. The loopback interfaces are reachable by protocol. Okay, now continue with the third router, 333. Here I will use the interface OSPF setup. So enable config T, interface range G00 and 2, or let's do it like this: interface G00 to 2 and L0, all of them. I'll first set them as IP OSPF 1 area 0. Then I will change the G01 to area 1. So interface range, let's write interface G01 area 1. To be sure, let's check. Okay, 10 is in area 1, 10.013. Okay. The one related with 10 is in the area 1, so and the loopback is also okay, it's in area 0. And let's continue with this router. IP address is already set. Enable config T, interface range G00 to 2 again, and L0. I'll put them all in area 0. Okay, only one interface is in area 2, which is G02, so this will be area 2. Okay, let's check. Area 2, only this one, others are 0. One last. Enable config T, interface G02. There's only one interface, so I will define it as area 2. The passive interfaces will be defined. Sorry. Router OSPF 1, passive interface L0. And I noticed I didn't define them, so I will define them here. Passive interface L0. And this one, passive interface L0. The ones defined by interface, I add them passive interface under the router OSPF 1. So let's check. Okay. Show running config, passive interface, and G02 on this one because of the switch. Now let's try pinging all the routers. First router, loopback interface. Second one working. Third one. Fourth is okay, and the last one. This is not reachable. Okay, there's a problem. Okay, let's check IP route. It cannot be reached. 5 is not here. So let's check from here. Actually, this will be a troubleshooting for us, I guess, in the end. Okay, and show IP OSPF neighbors. It's seen as a neighbor, so it's seen as a neighbor. There should be no problem. Routing protocol is defined. Okay, the address seems like okay, 1050. This is the fourth router. This one. OSPF. I first check the brief. That was 54. This is 55. Loopback is okay. Up. Down. Okay. Interface show run. This one IP OSPF 1 area 2. Okay. Seems like this one is missing. We defined the L0, but we didn't add into the routing protocol. Now it's working. Okay.